In this video, the learner will identify and model the undefined terms of Euclidean geometry and their intersections. First, I'm going to give you a little background on what Euclidean geometry is. Back in ancient Greece, this guy named Euclid was a geometer, which meant he studied geometry. He wrote a book called The Elements of Geometry, which had 13 volumes. Up until the last 200 years, it was actually the most printed book in all of history besides the Bible. So we've been studying geometry for a very, very long time. Now, his geometry is based off of what we call undefined terms. We're going to explore those in this video. The study of geometry requires us to make justifiable statements in order to build our understanding. But because an infinite series of definitions based on prior definitions isn't possible, that would just become one big infinite circle of definitions. We have to base our logical system on what we call undefined terms. These terms don't have formal definitions, but we define them using descriptions and examples. So they are what we call our undefined terms. Then with those undefined terms, we can then use them to define other terms. So a defined term is a term that is formally defined using a previously known word or definition. In Euclidean geometry, there are 3 undefined terms that will be the basis for all of our other definitions, postulates, and theorems. And these 3 undefined terms are point, line, and plane. As we start to use our undefined terms to start defining terms, and we build our logical arguments in what are called postulates as well, which are statements that are accepted as true without providing any proof. We accept those statements as being kind of common knowledge. And these are the first 5 that we're going to be looking at and using in our class, and I want you to have those in your notes, talking about points, lines, and planes. Also building our logical arguments as we move past postulates are terms that are both undefined and defined. All of the evidence that we put in all of our proofs, whether they be paragraph, 2-column, or later on flowchart proofs, we get that evidence from undefined terms, postulates, and formally defined terms. Once we have a conjecture that has been proven using those other things, then it turns into what's called a theorem. And a theorem is a statement that has to be proven true. So all of our theorems have already been proven. We can use theorems as evidence in proofs as well. So we're going to use all of these things to form our logical arguments as we move forward. A question that I want you to have in your notes and I want you to answer is, what is the difference between postulates and theorems? This question needs to go in the Q column of your Cornell notes and then answer in the body of the notes. Now we're going to describe our undefined terms, point, line, and plane. So for point, it's described as a location in space with no shape or size. So just a location, for example, point A here. We would name a point with a capital letter. So this point right here with the A next to it is named point A. A line is made up of points with no thickness or width. So those points R and T are on that line M. And a line extends infinitely in both opposite directions. So we have this arrow pointing this way to know it extends past R, and an arrow pointing this way to know it extends past point T. We name a line by 2 points on that line or by a lowercase cursive letter. So this lowercase cursive letter is not a point on that line. Notice it's not a capital letter. It is just the name of that line. So line M, or using the points line RT, Or we actually have our symbolic representation, our points RT with that line symbol above it. We can also reverse those and say TR with that line symbol above it. A plane we describe as a flat surface made up of points that extends infinitely in all directions. You need at least 3 points that are not on the same line to make a plane. So 3 points that are not on the same line, notice if we connected those we would actually make a triangle, which is our simplest surface that we could make. Now I've kind of boxed those in to kind of represent the surface, and those arrows to represent it extending infinitely in all directions on that two-dimensional plane, that two-dimensional surface. We would name it by a capital cursive letter, so notice that letter R there, or by 3 points that make up that plane. So here are the possible names for our plane here. We have plane R using that capital cursive letter. R is not a point on that plane. It is the name of the plane. We have point B, point C, and point D that are located on that plane. And we could use any combination of those 3 letters to name that plane. Some other definitions that we're going to use. Collinear means points that lie on the same line. So we have points R, Q, and S that are collinear on line M. So points R, Q, and S lie on the same line. We have coplanar points, points or lines that lie on the same plane. Notice we have points B, C, and D on plane R, like we had previously. Points B, C, and D are non-collinear, but are coplanar. It's important to know what non-collinear means. Non-collinear points do not lie on the same line. So notice B, C, and D do not have a single line that can go through all 3 points. But points C, B, and D are coplanar. They do lie on the same surface. It's also worth noting here, point C and line BD are coplanar. So not only can points be coplanar, but points and lines can be coplanar. We had non-collinear, which meant points do not lie on the same line. We also have non-coplanar, which would mean points that do not lie on the same plane, but they would be contained in the same space. Space is a boundless 3-dimensional set of all points. So it contains points, but it also can contain lines and planes. So we have an illustration here that kind of shows what space looks like. This is what we think of when we think of space. We think of stars and planets and the orbits. Well, we could think about the stars being the points if we connected 2 stars or planets together with, say, a string. That could be considered a line in space. If we had a slice of space, then that would be considered a surface. So like these dotted lines here, if we were to be able to take a knife and slice through space right there, that would be considered a plane in that 3-dimensional space. So we've talked about lots of terms. Using our undefined terms, we defined other defined terms, and then we're going to formulate arguments further on in the course with all of these definitions and postulates and theorems that we can make.